The rational theorem says if Q is the factors of the leading coefficient and P is the factors of the constant term, then the only rational functions you have are P divided by Q. This does not include irrational zeros or imaginary zeros. Example, f of x equals 2x to the fourth plus 4x squared plus 3x plus 8. So I want to know what are the possible zeros. Now when I say possible zeros, I don't mean what are the actual answers. I mean what list am I possibly going to do. So that's the key word, possible. So I'm going to take all my factors of 8. So all my factors of 8, 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. And I'm going to divide it by all the factors of my leading coefficient, which is 2. So 1 goes in, 2 goes in. And when I ask for the list of possible roots, yes, I want you to simplify it out. So you need to do, you need to do 1 divided by 1, 1 divided by 2. 2 divided by 1, 2 divided by 2. 4 divided by 1, 4 divided by 2. 8 divided by 1, and 8 divided by 2. You need to actually list out all the combinations. So 1 divided by 1 gives me 1. 1 divided by 2 gives me a half. 2 divided by 1 gives me 2. 2 divided by 2 I already have as plus or minus 1. 4 divided by 1 is 4. 4 divided by 2 is which I already have. 8 divided by 1, 8 divided by 2. So this is my list of possible rational zeros. So that basically means when I go and do synthetic division, those are the only rational numbers I try. That does not include any imaginaries, and it does not include things like radicals. Okay, so here's the second one. X cubed plus 5x squared minus 4x minus 2. So I'm taking all my factors of 2, which are 1 and 2, and I'm dividing them by all the factors of, there's nothing here, so it's assumed to be a 1, which is 1. So when I divide, I get 1 and 2. Those are my only rational numbers that I'm going to try in synthetic division. Next one, f of x equals 3x cubed minus 7x squared minus 22x plus 8. So I want to find my list of possible roots. So I'm doing all the factors of 8, which are 1, 2, 4, and 8. And I'm going to divide it by all the factors of 3. So my list of possible roots are going to be plus or minus 1 divided by 1 is 1. 1 divided by 3. 2 divided by 1. 2 divided by 3. 4 divided by 1. 4 divided by 3. 8 divided by 1. 8 divided by 3. So as you can see, we have a long list of numbers to try from. My suggestion is that you try the whole numbers first and save the fractions for synthetic division. So we're going to try to find one root because right now you have an x cubed graph. So if I can find 1 0 in here and get this down from a cubic to a quadratic, I can just factor the quadratic. So let's try. So this is going to be a little bit of guess and check. So my my coefficients for my synthetic division are going to be 3, -7, -22, and 8. And let's say I try 2 first. So that's going to give me 3, 6, -1, -2, -24. And as you can see, this is not, 2 is not one of my real zeros. So this might take a little bit of trial and error to find one. So let's try another one again. So I tried +2, let's try -2. So that's 3, -6, -13, +26, +4, -8, and I found one. So -2 is a root. Okay, so now we need to find the other ones. So I'm going to go on to the next screen and finish this. So on the last screen, I'm just going to put this up again. We had this. 3, 6, negative 13, 26, 4, negative 8, 0. So what this tells me is this is 3x squared minus 13x plus 4. Because remember, this is my remainder. This is my constant term. This is my x. This is my x squared. So now that I've gotten it down to quadratic, I know negative 2 works. I'm going to factor the rest. So if I factor that, that comes out to 3x and x, and then 4 and 1. If I want a negative 13 and a positive 4, and so my factors, if I want you to have them listed as factors, that's the minus 2 will give me an x plus 2. It depends on how I asked the question, and I don't remember what I had on the screen before, so I'm just going to list both. So if I ask you to list the factors, you list them in this method. You list everything here. The negative 2 is an x plus 2, and then I got these from factoring. If I ask them to list them as zeros, you would just list, this will give me a 0 of negative 2, positive 1/3, positive 4. You set each one of these parentheses equal to 0. So that's going to give me negative 2, a positive 1/3, and a 4 as my zeros. Okay. Now we're going to look at upper and lower bounds test. So if a polynomial f of x is divided by x minus c, if your c is less than 0, meaning you have a negative 0, like a negative 1, a negative 2, a negative 3, a negative 4, and every number in the last line of synthetic division alternates signs, meaning you go from positive to negative, etc., it's called a lower bound. And you don't have any zeros smaller than that. If your c is greater than 0, meaning you have a positive 0, like 5, 6, 7, 8, etc., and every number in the last line is positive, then it's called an upper bound, meaning you don't have any zeros higher than that. So if you have all positive numbers and you choose a number bigger, all that's going to happen is your zeros are going to get bigger and bigger and bigger, or all of your numbers on the bottom will get bigger and bigger and bigger. Okay, so let's take a look at this example. 2x to the 4th minus 11x cubed plus 2x squared minus 44x minus 24. I want to know what all the possible rational zeros are. So again, I'm going to try 24, which is plus and minus 1, 2, 3, 4, 6, 8, oops, I'm going to have to move over here, 12, and 24, and that's all over all the factors of 2, which are 1 and 2. So my list of possible zeros, we're going to do plus and minus 1, plus and minus 1/2, plus and minus 2, plus and minus 1. All I'm doing, in case you've forgotten, is I'm doing 1 divided by 1, 1 divided by 2, 2 divided by 1, 2 divided by 2, 3 divided by 1, 3 divided by 2, 4 over 1, 4 over 2, 6 over 1, 6 over 2, 8 over 1, 8 over 2, 12 over 1, 12 over 2, 24 over 1, 24 over 2. So let me finish my list. Oops. And actually, plus minus 2, oops, we already did this one. We don't need to write this twice. And then 3 divided by 1, 3 divided by 2. So I need plus or minus 3, plus or minus 3/2. And then 4 divided by 1 will give me 4. 4 divided by 2 I already have. So I need plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Those are my list to try. So let's... Okay, so I want to find my zero using upper and lower bounds to guide you. So what this means is I'm going to test some numbers. And first off, to see if I can get to be a zero remainder. Because since I have an x to the 4th graph, if I can find 2 zeros, then I can get it down to a smaller number. I can get it down to quadratic and factor it. So, but even if I don't have a 0 as a remainder, it will tell me a few things. So for example, 2, negative 11, 2, negative 44, negative 24. Let's say I'm going to test negative 1. That gives me 2, negative 2, negative 13, 13, 15, negative 15, negative 59, 59, 35. So even though this is not a 0, this tells me a couple things. I'm going from a positive to a negative, to a positive, to a negative, to a positive. Since I am going back and forth between positive and negative, that basically means that this is a lower bound. So I'm not going to try numbers smaller. So don't try numbers smaller than negative 1. So for example, I'm not going to try negative 2. I'm not going to try negative. So I'm not going to try negative 2, negative 3, negative 4, negative 6, negative 8, negative 12, negative 24. I'm not going to try those. Okay? So that kind of eliminates some of my choices. So I'm basically going to have to stick with negative 1/2 and larger. So I'm going to add another screen and work on the next page. Okay, so now we're going to try, we tried negative 1 already, and we found that that was too low. So now let's try a higher one. So I'm going to try 8 with 2, negative 11, 2, negative 44, negative 24. So if I do my synthetic division, that's going to give me 2, 16, 5, 40, 42, 3, 36. And as you can see, if we keep going on this, this is just going to get ridiculously large. So you can tell from this that these are all positive, so you're not going to try anything bigger than 8. So we're not going to try 12, we're not going to try 24. So let's try something smaller. Let's try 6. This gives me 2, 12, 1, 6, 8, 48, 4, 24, 0. And then on the 2, 1, 8, and 4, let's try a negative 1/2. It gives me 2, negative 1, 0, 0, 8, negative 4, 0. Which means I have 2x squared plus 8 left, and on the next screen I will finish that.